Okay, so now it should work because I didn't have the sound on. So we start with $100. It says how much will be in the retirement account in 2011, a year later. And we'll think about a few things here. We're going to start with $100. And what we do when we have interest is we want to make sure we keep that amount. Okay, so this will kind of explain part of this formula. You're going to have parentheses here. The 1 means 100 times 1, you're keeping that amount. Then we're going to have our rate. How do we write 4% in a decimal?
0.4.
No,
0.04.
0.04. So I have 0.04. And then we have our time that's up here at the top, which in this case is in 1 year. Okay, so think about what this means. Taxes, tips, anything that's adding is going to be this. If we add these together, that's 1.04, which is 104%. Okay, that means you're getting your money back plus another 4%. So put this in the calculator and see what you come up with. Because since it's to the first power, all you're doing is say 100 times 1, 100 times 0.04, or you could add the 2 in the middle to begin with. You get 104. So it says, here's 104. So how much interest did he earn in that year?
$4.
He only earned $4. Not very much. Okay, 2 years later. So we're talking about 2 years after that. What are we going to change? We have this, right. We've got, this is the first year. We want another year. We want to take everything that we had for this year, and we want to do this again. Okay? I'm going to show you how we simplify just a little bit later. So put both of those in and see what you get for this one.
108.16.
And we could simplify this formula a little bit by saying, here we have 100. We have 1.04 squared. So you can put that in also. You're going to get the same answer, whether you put it this way or whether you use your square. So, how much interest did he earn the second year?
$4.06.
That's 8. Well, think about it. He had 108.16, and he started with 104 that year. So he had 416 because he earned more. So the question is, like, why is this different than the first year? Why did he earn more money this year than last year? Okay, because the interest the first year, he started with $104 the second year, not 100. Because he earned a little bit more. Let's do one more here. 3 years later.
$112.49.
Give everybody a chance to do it. So we can write this formula out the entire way because we have our first year, second year, third year. Put it all together. Or we can simplify this a little bit, which is what you're going to want to do, because you're talking about 50 years, you're going to want to write this 100 times. So we can say we have 1 plus our rate, and now we have 3 years. Everybody make sure you can get this in your calculator. Okay? I know Dylan said it and I already put it up here, but you need to make sure you can get that. Don't just write it down because somebody already said it. Make sure you can put this in 100 parentheses 1.04 closing parentheses to the third power. And if you're talking about third, fourth, so on, you're going to have to use your exponent key. So if he has 112.49 for this year, he had 108.16 at the beginning of the year, how much interest do we have this year? Okay, $4.33. So if we're looking at our table up here, For 3, we had 112.49. And we can continue. I think it asks you down at the bottom, it says, what can be used to find after X number of years? This is what I simplified up here a little bit. We have whatever our principal amount is. Like I said, that's our initial amount. This is the formula that you need to write down. In our case, it was 100. Okay, so we're going to say we had 100. And we'll simplify this again in a minute. 1 plus 0.04. And since X is our years, that's what's changing. The rest of this isn't changing. So this part is our initial amount. This stays as 1. This is your rate. And these are your years. So what can change in this is the years, the rate, and your initial amount. If you look at the next question, says, what do you notice about the dependent quantity? If you divide all of your y values up here, what are all of these changing by?
4.
Divide these. Divide 104 by 100, 108 by 104. What's the difference?
1.04.
1.04, which is our amount. If we add this, okay, that's our rate, and it's in the middle. So it's not a coincidence. It should happen. So if he's going to have 40 years, how much will be in the retirement account at that time? Let's use our formula. Find out how much money that he's going to have after 40 years.
$480.2.
Okay, so would you want to invest in this account?
No.
Mm-mm. And the reason this is lower is that it's only being calculated once a year. So if it was being calculated all the time, then it would be a lot more money than that. That's one thing you would want to check.
So the question is, what do you know? This is it real quick.
And this is your formula in general that you're going to use. And I talked about it a minute ago, but I want you to label this just to be sure. This right here is A. This is your amount in your account, okay, or your account balance. It says how much money will you have after this amount of time. This one, the P, is what we call principal. Or you might think of it as initial. The amount that you start with. R is your rate, which is going to be your percent. You need to always remember you change it. It should be a decimal unless for some reason you had like 200%. Or you made your decimal 2 places, you'd have a 2. That's not going to happen. And then this one up here is your time in years. And so this is an example of an exponential growth function. You put years. Like RS.
Oh,
Years.